Hello, we're going to continue talking about equations of lines, specifically parallel and perpendicular lines. So our objectives today are students will be able to recognize parallel and perpendicular lines from slope. Students will be able to create equations for lines satisfying the criteria of contains a given point or and is parallel or perpendicular to a given line. So some of the vocabulary that you're going to deal with today are slope, perpendicular, parallel, point slope, slope intercept, and standard form. And we're going to give you a couple different examples, really walk through the strategic reading that would be involved in this, and then go to some more difficult ones that you may not encounter on a test, but if you did, I wanted you to have the support so you could be successful with them. Okay, so it says given a point in a line y equals 2x minus 8. And again, y equals mx plus b. We have slope intercept form, and that'll allow you to identify the pieces and parts. So what is the slope of the line? We know m stands for slope, so m is equal to 2. And if I use the complete sentence, the slope is 2. A little reminder that that's 2 over 1 so that you can get your rise over your run relationship. What is the slope of any line parallel? So keyword there, parallel. We know one specific thing about parallel lines is that from our earlier units that they have equal slopes. So if I have an equal slope, that means any line parallel to this must also have a slope. Any parallel line will have slope of 2. Then it asks us to write an equation of a line through the point and parallel to the line. So since it's going to be parallel, again, annotate same slope or equal slope, which is 2. I want to go through the point. The point they provided is -3, 6, which in turn means x equals -3 and y equals 6. And then you can write this equation in a couple different forms. Y equals mx plus b will work, but let's keep familiarizing you guys with point slope formula. And so y minus 6 equals m, which is 2, x minus -3. So this will turn into y minus 6 equals 2, x plus 3. Y minus 6 is equal to 2x plus 6. Just be very, very careful when you're looking at a problem like this that you go through and use your fundamental algebra. It's very tempting that because I see 6 on both sides not to follow through with putting this plus 6 and plus 6, but my equation is y equals 2x plus 12. Oftentimes people will just make that a 0 because they see a 6 on both sides. What is the slope of any line perpendicular? Again, if it's perpendicular, I want you guys to write perpendicular out and then negative reciprocal to the given line. And so perpendicular lines have negative reciprocal slopes. Therefore, the slope would be -1/2. And that stems from taking the 2 over 1, and its reciprocal would be 1 over 2, and then negating it. Okay, that's a pretty basic question along the lines of here's an equation, here's a point, can I make a line parallel or perpendicular through a separate point? The next two examples kind of make you think just a little bit, and you might want to draw a picture to validate visually what you're trying to do. And it says, find an equation of a line through the point square root 3 and 1/2 parallel to a line. And so if I quickly just give myself a sketch, I do have to remind myself that the x equals -9 is a vertical line. If I want to be parallel to that through the point, now this is approximately 1.7, so if I were putting a scale on there, this would be somewhere around that. If I want to maintain being parallel to this, I'd have to be another vertical line, which means I'm strictly in x equals, and that x equals is square root of 3. And so a lot of this comes from understanding what it means to be parallel, same slope. What's the slope of an x equals line? Well, it's undefined because it's a vertical line. If I know I have to be parallel to a vertical line, I have to maintain being a vertical line, and therefore I have the x equals square root of 3. Very similarly, as you're going through and you're looking at negative square root 7, it's somewhere right here. Here's x, or I'm sorry, lost track of not doing x's any longer, I'm doing y's. So let me resketch this for you. So the y equals square root 7, but negative. So here we go, final graph. Okay, so I would label this y, horizontal line. So if I want to stay parallel to that, I also have to have a horizontal line. I want that horizontal line between square root 3 and negative r and 1/2. So square root 3 is right there. And so my graph would end up going likewise through that point horizontally. That y value is 1/2. So I get y is equal to 1/2. Because I know it's a horizontal line. I know that this slope must be 0. All those details. And then it says, what can you conclude about your answer in parts A and B? When lines are parallel, slopes must be equal. So a vertical line is parallel to another vertical line, and a horizontal line will be parallel to a horizontal line. A vertical line, remember, is an x equals line, and a horizontal line is a y equals line. And so you just pick the coordinate x or y based on that. Okay, next one, crazy numbers. Find an equation of the line through this point, negative square root 2 and pi, parallel. Again, parallel, if we annotate this, I know it has to have equal slope to the line x minus 7y equals the square root of 5. And right at the moment, I don't actually know the slope because it's not in slope-intercept form, so I might have to do a little bit of work. And let's write this. So subtract the x, subtract the x. So I have negative 7y equals negative x plus the square root of 5. Divide everything by negative 7. And so y is equal to 1/7 x plus the square root of 5 over negative 7. Now, in all honesty, I'm not really paying much attention to the y-intercept. I'm solely paying attention to the slope. And since it's supposed to be an equal slope, that means that I really just need to work on this m equaling 1/7. Okay. And so, point slope formula, y minus y1 equals m times x minus x1. So y minus y1, which is pi, equals the slope, which is 1/7 times x minus negative square root 2. Y minus pi equals 1/7 times x plus square root 2. Make sure you remind yourself of that. Minusing a negative acts the same as adding. Y minus pi is equal to 1/7 x plus square root 2 over 7, and then I add pi to both sides to get y is equal to 1/7 x plus square root 2 over 7 plus pi. And notice how I couldn't combine those two. They're not really like terms, and so this is your equation. Last one. This probably gives you at least the understanding of why equal slopes end up being parallel lines. You are able to, with the slopes, keep an equal distance between the two lines at any point that I look, because of the ratio between the slopes. So given the statement AB is parallel to DE, construct an argument for or against the statement using the two triangles shown below. And as I look at these two triangles, I see that that is 6 and this is 2. I see that this is 3 and this is 1. And what I understand is that if I were to look at the slope, it's the delta y over the delta x. And so if I'm comparing these, 2 over 6 is equal to 1 over 3. So slopes are in equal ratios. And if I really wanted to, I could kind of like make a secondary triangle within it. And now I have a 3 versus a 1. And so a nice sentence would, the triangles provide for a comparison of equal ratios. And therefore, lines are parallel. Again, remember, understanding the lines are parallel really depended on our understanding that these distances were maintained as equalities. Okay, so your takeaway or summary from today is that parallel lines have equal slopes. Perpendicular lines, as we've learned in the past, have negative reciprocal slopes. Really, really important that as you're annotating these that you write those words in each time. It's really helpful for you. Thank you for your time.